Okay, guys, here I am recording the podcast for Lab 3.4. And the only thing that really matters in this lab are these calculations. Obviously, there's a bunch of typos up here. I do apologize about that. The first thing I told you to do is make sure this was kilojoules and to make sure that all of these were joules. I think it's important to remember that delta S is given in joules, and what we're going to need to do is convert delta S to kilojoules by dividing by 1,000 every time we're going to use this equation. Okay. So initially we see formation for delta S and delta H, so we're going to use our products minus reactants formula. So I'm going to set that up for each. For part 1, A2B3 was the product, and A and B were the reactants. So A is multiplied by 2, and B is multiplied by 3. Okay, so here is A2B3. It's negative 286, and we're going to have 2 times 52 for A, and 3 times negative 32.9 for B. And we're going to get an answer. And that answer for delta H should be negative 291.3 kilojoules per mole. Okay. And let's expand this a little bit. Okay, for delta S, we're going to do the same thing, but we are going to use values here. Now we can keep these at joules and do the conversion at the end. That's fine. So this should be 189 minus 2 times 219 plus 3 times 242, and that answer should come up be negative 975. And what we're going to do is divide that by 1,000 to get it to the units we need. So kilojoules per mole. So what we had was 975 joules, and we divided by 1,000 joules in every kilojoule to end up with that number right there. So we're looking for delta G. We came down, we grabbed the things we needed, and we're going to pull it right up to the equation. Delta G is equal to delta H, should be negative 291.3 minus T, and it depends on which class you were in. But I believe most of the classes it was around 27 degrees Celsius. I think in block 3 it was 24 degrees Celsius. So you're going to add 273 to this, and I'm going to use this value. Okay, so this is, this is going to be 297 Kelvin there. So this is going to be 300, and this is going to be 0.975, and overall delta G value is 1.3 kilojoules per mole. So based on this answer, it's non-spontaneous because delta G is greater than 0, but we know this reaction was spontaneous. Remember, all of these numbers are just hypothetical. It's just a totally hypothetical lab situation. All right, so let's do part 2. Okay, part 2, I see the formation for H and F, and let's look at the reaction here for part 2. It was C plus 3D goes to CD3. So C plus 3D goes to CD3. So delta H, delta S, and then we're going to calculate delta G down here. So products minus reactants. 1 times CD3, which is negative, this should be kilojoules, remember, and these are all joules. Negative 84.7. All right. And 1 times negative 1207 plus 3 times negative 110.7, and we should get a negative 1537.6 kilojoules per mole. That's delta H. Delta S, products minus reactants. Product 229.5. Reactants, I told you this is 93. 93 plus 3 times 198 because of that 3 there. And our overall answer for delta S should be negative 367, and we're going to divide that by 1,000 to get it to kilojoules. So delta H minus T delta S. My delta H is negative 1537.6 minus 300 Kelvin, because I told you this was happening at 27 degrees Celsius. You're going to add 273 to get 300 Kelvin. Okay, that's the temperature. And negative 0.367, which I got from there. And this is negative 1426.9 kilojoules per mole. Okay, the most important things that I need you guys to do in this problem is to convert delta S to kilojoules, okay, and to convert the temperature to Kelvin. That's very, very important. Do the formation equations with H and S, and then plug into delta G. All right, have a great day. Take care.